Welcome! This video has some tips for working with structs. So the first important thing to realize when you're dealing with structs is that a struct is just a definition of a data type. It doesn't actually store anything itself, it just defines a new type of information. Struct student says, hey, there's going to be this new type of information called a student, and it's composed of a name, a quiz average, and a lab average, which are respectively a string, an int, and an int. So it's a way of building complex data types from more simple ones. But creating this data type doesn't actually create a particular student. To do that, we have to say something like, okay, make me a student called S1. Much like we'd say, make me an int called x. All right, this is the identifier, the name of the variable. Its type is not int or double. The type is student. So what does it mean to be a student? Well, it means that we've got these three components. And to access those components, we use the dot operator. So s1.name says go to student1 and access the name. Go to student1, access the quiz average. Set it to be 84. In memory, what we'll have is something like this, where the different components of the student are just laid out in consecutive blocks, and behind the scenes, C++ does the work of figuring out, okay, if we're accessing the name, we need to go here and grab that chunk of information. If we're accessing the quiz average, we go here, etc. But from our perspective, we just say, go to the student, access the name. Now, it only makes sense to talk about the name or the quiz average or lab average of a particular student. It never makes sense to say something like student.name. If I build this and try and compile it, I get this error, unexpected unqualified ID before dot. Basically, it's saying this doesn't make sense as something that comes before the dot. I can't talk about the name of student because which student is that? That's like saying int equals 10. Well, what int? X, Y, Z, which variable? So we always have to talk about a particular student that we've created. And we can have multiple, so I can have student S2, and maybe S2's name will be Jane. But we always have to talk about a particular student or a particular instance of whatever kind of struct we're dealing with. Kind of like initializing an array, you can initialize a struct with values. You have to list them in the order that they appear in the struct, so I have to have name, quiz average, lab average. If I don't have something specified, from then on becomes zeros. But so you can see I make S2 and print it out, and it's got the right information. We can copy a struct. So if I have student S2 gets assigned S1, this will go through and piece by piece copy all the information from student 1 to student 2. But now they are separate things, and if I start modifying student 2, student 1 will be just fine. It will not get changed. Otherwise, there's basically no aggregate work we can do. I can't compare two students. I can't read in a student from the keyboard or print out a student automatically. Basically, anything I want to do, I need to do with members. So if I want to compare two students, I need to compare, say, their quiz averages or their names or something else. If I want to print out a student, I need to do either print out just their name or print out piece by piece their name, their quiz average, their lab average. But everything has to happen kind of piecemeal with those individual members. Now we can use structs just like any other data type, so I can use them as parameters for functions, but I've got to be careful. So here is a broken function. Increase quiz average. Takes in a student and how much to increase their average by. So we're going to add the new average bonus to their existing quiz average. right, to student S. And so I take student 2, I pass them into this function with 10 to try and increase their quiz average. I print out Bob Smith before he goes in, increases the average by 10, print him when he comes out, and nothing's changed. So why has this happened? Well, the process of passing the student to the function is essentially doing the same thing that we did here. We're making a copy of the student. We can see this if we're kind of careful with the debugger. I can stop the program right before it gets to the function, and I can look at student 2, and in the debugger, if I look at a student and I crack them open, I can see the individual parts of the student, and it shows me the memory address of the student. So I can see that student 2, who's being passed into this function, Bob Smith, is at this location in memory. Once we go into the function, right, we have this parameter s, so s2 gets copied into s, and inside this function I can go look, and sure enough it's got the same information, Bob Smith 92 and 84, but we've copied it to this new location in memory. Right, so now we're at 28FE94 versus 28FE7C. Any changes we make in here to this student will not affect the student that we were originally working with, because we essentially have two copies of the same student. So to make this function work correctly, we have to take in the student as a reference parameter. Right, that's the way, if we want to modify a variable inside a function, that's the way we do it, with the exception of arrays, which are kind of special and weird. But so just like if I want to modify an int inside a function I'd pass in by reference, I can do that with a student. So I could rewrite this function to take in s as a reference, and now it works correctly. I pass in the student, bump up their average by 10, and now Bob's got an average of 94. And if I do the same trick with in main, looking at it in the debugger, I would see something like this, and Bob's memory address is 28FE88, and once I go into the function, it would be at this S would be pointing to the exact same location, 28FE88. So the student I'm working with in here, who I'm referring to as S, is really the same thing as S2 was out in main. Now, we use references for two reasons. One, so that we can modify the original, and two, so we can avoid the work of a copy. Right? This student isn't too bad, just 3 pieces of information, but sometimes structs are very large. And just because I pass one into a function doesn't mean I want to go to the work of copying piece by piece everything over. So it's very common when you're working with structs to pass them by reference no matter what. And that way we're not making a copy. We're saving a little time and effort. But if I don't want to modify the student who I'm passing in because I'm just doing something like printing the student, then I want to make sure I take in the student as a const so that I can't mess it up and the compiler will stop me if I try to. So, kind of rule of thumb should be, if you want to pass a struct into a function and you need to work with a copy of that struct inside the function, go ahead and do normal pass by value. Right? It was broken for this function, but if I wanted to actually be working with a copy of the student and not the original, this would be perfect. If you need to modify the original, then pass by reference. So this would be the kind of correct version of this increase the average of a student. And if you want to pass in the student, you don't need a brand new copy. You're not going to make any changes, and so you don't want to be able to mess up the original, then pass it in by a reference, but do so with a const modifier. So the compiler will protect you from yourself. Structs can also be returned from a function. Right? So I can have a function build empty student that says, okay, we're going to have a student called new student. We're going to set their name, quiz average, and lab average to be some just kind of placeholder values, and then return that student. In main, I could use that by saying, okay, build me an empty student, and I can see it's going to return this student that it made, I'm going to store that as S3. And then I could pass that into my print student function and see the information. Now this one's a little bit silly, but we could take the same idea and make a more complex one that does something like take in a string formatted like Bob Jones, comma 84, comma 92, something maybe we're reading from a comma separated file that came from Excel, and we're turning that into a student. So we'd declare a new student inside the function. We do the work to break up the string to like find the comma and grab the name and then grab the numbers. If you want, you can go check out the code for this example as the simple student and do the rest of the work and then return the student that we created. Return this new student. And back in main, we'd just do something like this, except we'd say parse student and pass in the string that we wanted to parse. Now, a struct can be built from these primitive pieces, but they can also be built from other structs. We can use structs to build more and more complex things. So I could have a struct for a name that consists of a separate first, middle, and last to make it easier to do printing things like last comma first or printing the initials, right? I could have more flexibility with how I dealt with someone's name. I could have a struct representing a date that has an int for the year, month, and day. And then I could define, using those two, a struct for a student that consists of a name, a birthday, which is a date type, and the name is a name type instead of a single string, and then the quiz average and lab average. And I could initialize my date with 3 ints, my name with 3 strings, and my student with a name, a date, D1, and these 2 ints. Once I did that, if I go peek at in the debugger, so I declare a student S1 and I've initialized it, it's going to look like this. Right? Student consists of the birth date, lab average, name, quiz average. And the birth date and name, I can see their type is date and name respectively. I can crack those open and go look at the individual pieces. Then to access the parts of this student, right, I have to kind of drill down with that member operator a couple times. So if I want to access the last name of student 1, I have to say, okay, student 1 has a name that's defined in the struct. Student consists of name, birthday, quiz average, lab average. So go to student 1, get their name, and the name, well, that name is a struct with a first, middle, and last. So from that name, I want the last part. And so drill down to what I really care about. And then go to student 1, go to his name, give me the first, and then I want to see the year he was born in. So go to student 1, get the birthday, which is this date type, and in it I want the year. So print that out. And I'd get something like Jones, John, born 1992.